This is Mr. Martin. These are video notes for Geometry Advanced. We're moving on to Chapter 12. We're going to talk about trigonometric ratios. This is one of the most important units that we're going to be studying this year because um, there's some great applications of trigonometric ratios, and you'll be using these concepts in future math classes as well. So by the end of this video, you should be able to solve for missing sides of a right triangle using the trigonometric ratios. So let's start off with what exactly trigonometry is. So trigonometry is the study of the relationships between the sides and angles of triangles. So mostly we're going to be dealing with right triangles, but trigonometry does apply to all triangles. So trigonometry has origins in astronomy. The Greek astronomer Ptolemy used tables of chord ratios in his book The Almagest, and the chord ratios and the related angles were used to describe the motion of the planets. So here's a little wood carving. Before we get on to the meat of the lesson here, let's take a little flashback. So using skills learned in previous units, determine the missing side lengths. So go ahead and pause the video and see if you can work this out, and then when you come back we'll have the solution there and we can go through it. So hopefully you got 140 for the missing side here. And basically we can prove that these two triangles are similar by angle-angle similarity because they have tick marks denoting that angle R is congruent to angle E. And we have the measure of angles S and F, and we see that they're congruent. So we have two angles congruent, which is enough to show that the triangles are similar. And then what prior knowledge did you use to solve for the missing side lengths? Well, the sides of similar triangles are proportional. Okay, and this fact let us set up this proportion, which then we could solve and find the missing side. So there's a little flashback. Now let's look at some similar right triangles. So when studying right triangles, early mathematicians discovered that whenever the ratio of the shorter leg to the longer leg was close to a specific fraction, the angle opposite the shorter leg was close to a specific measure. They found this and its converse to be true for all similar right triangles. So let's take a look at these examples here. So I have these similar right triangles, and notice that all of these angles are 31 here. And if we look at the ratio of the longer leg to the shorter leg, for this triangle it's 3 to 5. For this triangle it's 9 to 15, which reduces to 3 to 5. For this one it's 3 to 5. So if we want to try and use this fact here, what do you think would be a good approximation for the value of x? So if we want to make sure that this stays in a ratio of 3 to 5, then x would need to be 33. Alright, and as usual, if you have questions, feel free to pause the video and write those down and ask me when you see me. Okay, so let's talk about the parts of a right triangle. We know that it has legs, and we know that it has a hypotenuse. And it's going to be more useful for us to be talking about the legs in relation to which acute angle in the triangle we're looking at. So for example, this triangle ABC here has an acute angle at A, and it has an acute angle at B. And you notice our little girl here is standing at angle A, and in the next example, she's standing at angle B. So it's going to be very important that you know which acute angle you're kind of standing at or dealing with. And I like to draw a little stick figure in there most of the time to kind of draw my focus to where I'm standing. So if we are standing at angle A in this first picture, we want to name the hypotenuse. So the hypotenuse is going to be segment AB. And then we want to name the side opposite angle A. So if I'm at angle A, the side opposite it is clear across BC. Okay, and now we want the side that's adjacent to. Adjacent means next to. And that's going to be this side right here. Let's put my segment symbol over there, which is just the letters of the triangle that are on each side. Then this would be side C. Opposite would be side A. And the adjacent would be side B. We can use either ones that you want to. I prefer the segment names. Alright, so now let's move little Sally over to angle B. And now our opposite side is going to change. So let's start with the hypotenuse. The hypotenuse in the triangle stays the same. Here's my right angle, which isn't marked. So that's going to be segment AB. Now the side opposite to the acute angle that Sally is standing at, we're going to go clear across the triangle to pick out the leg. That's going to be AC. And now the side adjacent to her, the side next to her, is side BC. So let's take a look at what happened here and here with the opposite and adjacent depending on which acute angle she was standing at. So what do you notice about the opposite and adjacent sides when you switch to a different angle? Well, they switch also. Okay, and this is important because your opposite and adjacent sides depend on where in the triangle you're standing, which acute angle. Important note right here, we always are going to be standing at one of the acute angles. We never ever will be standing at the right angle. Okay, so your turn to try on these two triangles. So for part A, we want to label each side of the triangle. We want to label hypotenuse, opposite, and adjacent. If we're standing on angle B. And then for part B, we want to label each side of the triangle if you are standing on angle C. So go ahead and pause the video, and then when you restart, you'll see the sides of the triangle labeled, and you can check. So pause the video now. Alright, so let's take a look at part A here. Notice I've got BC as the hypotenuse, and then the side clear across the triangle from our stick figure is the opposite side, and then the side right next to the leg, that is, because the hypotenuse is also next to this acute angle, but the hypotenuse doesn't count as the opposite or the adjacent. That's, again, the important point I want to make here. So that's my adjacent side, and then when we walk over to angle C, now the opposite side is AB and the adjacent side is AC, and again the hypotenuse stays the same. Okay, and a lot of times I'll just use H, O, and A to label the sides. Alright, so make sure that you're starting to learn that when I use H for hypotenuse, O for opposite, A for adjacent, and it's just a little shorthand to make life easier for us. Okay, so if you have any questions about opposite and adjacent and how to figure out what they are, make sure that you figure that out, because that's one of the most important things in this lesson. So this will be the end of this video. Again, if you have any questions, now would be a good time to get those asked before you move on to the next video. And in the next video, we're gonna talk about the 3 trigonometric ratios you may have heard before or seen on your calculator, the buttons on your calculator for sine and cosine and tangent. So we'll see you in the next video.